Okay, so this is the second video. Ooh, I pressed the wrong thing. So this is the second video that we'll talk about. We're going to be talking about from names to formula. Yeah, names to formula. We're still talking about metal and non-metal, but we're going to have polyatomic ions in the mix. Okay. So polyatomic ions, let's talk about what they are first. So polyatomic ion, this is a common list of polyatomic ions. The thing is this, when certain molecules, when certain atoms connect to each other in a certain way, they have their own specific property. So for example, hydroxide here, when you have an oxygen connects to hydrogen like this, it kind of acts and behaves like a base, okay? So that's hydroxide, and that's why most bases you see will have an OH like this. Ammonium, stuff they use to clean windows or cleaners, you have a nitrogen connect to 4 hydrogen, and we have a positive charge. So again, that will be another example of polyatomic ions. So you see this is a list of polyatomic ions, and so how to use them. So let's use a simple example right now. Lithium carbonate. Let's just say lithium carbonate. That's a first example. Okay, again, lithium from last video, lithium should be +1. Carbonate, if you look at this list here, is -2, 2 minus. So you have CO3, 2 minus. Again, you would do crossover rule. Now, this is the thing. Let's look here. Sorry, the 2 minus goes to the lithium, so it's Li2. The CO3, the +1 go to CO3. So in some ways, it is only one of the CO3. Okay? So in this case, it's almost like this. You have a bracket because it's the entire CO3, 1. So again, in chemical nomenclature, we make the 1 invisible. So in this case, the final one, it will be like this. CO3, you can make the 1 invisible, and since there's only 1 of CO3, you don't need the bracket anymore. Okay? So it's Li2CO3. Let's use another example. Let's do something like calcium carbonate. Actually, you know what? Let's do something like aluminum. I like aluminum. But aluminum carbonate. So aluminum, from the chart, it is at Al +3. Carbonate, again, it is CO3, 2 minus. Okay? Now, same thing applies. So you have crossover rule. So this +3, it goes to the entire CO3. And you throw away the sign. So it will be CO3, and you have a whole bracket and the 3. The bracket is there to show there are 3 CO3 groups. Okay? The 2 minus, you go to Al. You throw away the sign, so it's just 2. So the final formula will be Al2CO3, 3. Okay? Last but not least, I'll do one that you have to do some reduction. So let's do the calcium carbonate, the one that I was about to talk about. Calcium is +2. Carbonate, we'll keep on using carbonate. 2 minus. Okay. So again, crossover rule. The +2 you give to the entire CO3 group. So it will be 2. The 2 minus, you give it to the calcium, so Ca2. Okay. Now, this is the thing. I was going to say earlier, you're going to have to do reduction, but I don't really see the reduction. Now, when you do reduction, check for reduction, you look at this number as well as this other number. It is really the number that get crossed over, not the number inside the bracket. Okay? I'll repeat again. It is the number that get crossed over, not the number in the bracket. And so since these are 2, you can technically reduce them to 1. So in this case, you have Ca1 bracket C CO3 1, or you make all these invisible, which is CaCO3. Okay, so I hope this helps. Let me know if you have any other questions. Good luck on this. Bye now.